The example we're going to be looking at for the R code for chapter 15 is I went and took the bills for the current apartment I'm living in. I've been here 21 months now, and I've looked at the electric and the gas bill. Could have looked at the internet bill, but that's the same price every month, so not all that interesting. Whenever you're doing clustering, it's always a good idea to go ahead and plot your data. In this case, we have exactly two variables, makes it easy to plot. If you don't have two variables, if you have three or more, then you can always use principal component analysis, what we looked at in chapter 12, and plot the first two. And looking at the scatter plot of the data, we have electric and gas, and there appears to be 2 months with high electric bills and 2 months with high gas bills. And if you use this text line, essentially what it's going to do is whatever labels you feed it, that'll be a name it puts on top of the dots. We can give it which month that particular dot belongs to. And the 2 months that had the high electric bills, above 60, July 18th was the first month that I moved in, and that had a $30 activation fee. And August 19th of last year was really hot. Makes sense. The July of 2018 was also really hot. So it makes sense that those 2 months are high. And then last year, February and January were really cold, so it makes sense the gas bill was really high for those two particular months. But overall, there doesn't appear to be any clear pattern or clustering groups to the data. So we'll let the algorithms kind of tell us how many clusters there appear to be. First thing you want to do is, if you're going to use the functions built into R for this, is you want to calculate a distance matrix. And if you just use the distance, dist, and then the data you want to use, it'll use Euclidean distance. And it's generally a good idea when you're doing this to scale the data first, so that way the variance in the gas bill and the variance of the electric bill no longer plays a role. If two variables have very different variances, one variable then could have a stronger influence on the result of the clustering algorithm than another one does. But the variances are somewhat comparable between electric and gas. And the first time I did this example, the results without scaling it worked out a lot better than the results when I did scale it, so I decided not to scale it. But the other examples that you can find on Blackboard, I scaled the data first. And what the first step of any agglomerative hierarchical clustering method is going to do is it's going to look for the distances in here between any 2 months. It's going to look for the smallest one, and that's the one it's going to join together first. If we look, it appears that the smallest distance is the 0.66, joining August 18th and October 19th. And it's kind of hard to tell because of the labels, but those are these two dots right here. They're really close together, so they're going to join them together. And that's the first step. These two also appear to be pretty close, so it wouldn't be surprising if the algorithm decided to merge those together next, or these two together next. But which groups it joins together after the initial one is going to depend on the method that we use. And we're going to be looking at 6 different ones: single, complete, minimum distance, maximum distance, average, the average distance between the number of the dots in the clusters, centroid, where we look at the differences in the averages of the two clusters we're comparing, median, which does average, but instead of taking an average distance, it takes a median distance, and then wards D, which is a much more complicated way of measuring the distances between two clusters. Other than that, you just want to fit hclust, give it its distance matrix, and which method you want to use. And what it's going to return is it's basically the function itself is just going to give you 3 pieces of information. It'll give you the method. In this case, we use single for the first one. The distance that was used to measure how far apart these dots are. And if you don't give it anything up here, defaults to Euclidean distance. And then the number of objects, basically how many dots have been here 21 months. So there are 21 dots. And for all 6 methods, what we can do is if you do plot.asDendrogram, give it the clustering model that you fit, it'll spit out the dendrogram of it. And it'll start off by merging the first two together. October 19th and August 18th, we saw those were the smallest in the distance matrix, so those are the first two it merged. Then it appears to merge September 19th with this one, and then October 18th with this one, and then January 20th, March 19th. And so the order of the heights are the order that they merge those clusters together. And what we really want to look for is where the large jumps start, where the large distances before they start forming clusters together. And it appears that the last two clusters they join together are far apart. And then clusters 2 and 3, not so far apart. This is a fairly short distance. And then the next jump is also pretty large because these two are almost the same level, almost the same distance apart when they join them together. And this is a fairly large jump, almost as large as the last one. So maybe using single linkage, we'd want to use either k is equal to 2 or k is equal to 4, because those are our two really large jumps as far as the distance between clusters being merged together. These two distances are almost the same, so I'll go ahead and use k equals 4. And if you do rect.hclust, it'll draw a rectangle around the 4 clusters that we're forming. And it makes it easy to see which clusters we're joining together. So it appears we have December, April, March, and November for one cluster. December, February, January, March for another one. May through October for another cluster. So those appears to be the summer months. And then February and January of 2019, the two really, really cold months. So this cluster makes sense, your summer months. These two appear to be colder months, and then really cold months. If you want to store which cluster they got put in, you can use this cut tree function. You fit it the hierarchical clustering model you made, and how many clusters you want to form, k equals 4. We can do the same thing for complete, just run the same 3 lines of code, but change the model that we're looking at. In here, there appears to be 3 clusters we'd want to join. Large distance between the last two, which makes sense because what complete linkage does, if we go back to our scatter plot, now when it's going to join 2 clusters together, so let's say it joins everyone down here and these guys up here, it's going to take the dots that are the farthest apart. So the 2 dots that are farthest apart are probably this one and this one. That's a really far distance away. So that's going to indicate that really large jump that we saw in our dendrogram here. There's also a fairly large jump merging 2 and 3 together, and then a lesser jump going between 3 and 4. So judging off base this dendrogram for complete linkage, recommend 3 clusters. If we use that rect.hclust function again, it appears to makes somewhat sense. Really cold months, warm, coldish months, and then the summer months. Another thing that this rectangle function does is if you look at the flat line above it, the merger line, this distance is going to be halfway. So if we take this distance and double it, that's a pretty large distance, indicating that these 2 clusters that they join together are pretty far apart. So it makes sense to keep them separate. And then we'll form the 3 groups of these clusters. Going through, next we're going to look at little more robust methods. Single is the minimum distance, complete is the maximum distance. Those tend to be susceptible to outliers, as mins and maxes tend to be. Averages tend to work a little in between single and complete. So if we form the dendrogram for those, it appears that it also believes there should be 3 clusters, but the clusters are a little bit different than the one that average linkage made, or a complete linkage made. And if you notice, these have, the smallest one is 4 months in this one, whereas what average linkage did is it took the 2 months that were really cold, formed them in their own cluster. Then we have your typical winter months and your typical summer months. If we look at the centroids method, we end up with pretty similar results. Your winter months, really cold months, and then the summer months. So it appears that those 2 methods agree with one another. And then it even places the same months together in the clusters. If we look at the median, if we create its dendrogram, it also appears to agree with 3. So the ones that are more based off of looking at all of the dots in the clusters together all appear to agree with one another, at least somewhat closely. And then using Ward's method recommends 2, it appears. At least maybe this is a pretty large jump, but it's hard to tell because the jump between the last 2 clusters is so big, it dwarfs everything else. Maybe there should be 3, but there's definitely a huge gap between the merger of the last two, so we'll just go with 2. And lastly, what you can do is you can actually plot the results and see how they group them. We have 6 different linking methods, so we'll have 6 different plots. And what this line is going to do is it's going to make the plots in 2 rows and 3 columns. I say PCH19, so that way all the dots are filled in. And then what you can do is you can use the same plot function that we did at the very beginning, feed it the same information. I'm just going to add what link method was used, and then COL for color. If you give it the groups that we formed by using this cut tree function, it'll create a different color dot. So we can plot all 6 of them, see how the results compare. It appears that single linkage is we have these 4 groups, and we could probably merge some of these 2 here together. Maybe these 2 can go down here, or the red and the black we could probably merge together in their own groups. Kind of like what complete linkage did, is we had 3 groups there, and we have these 4 black dots, these upper red dots for the colder months, and these green dots for the warmer months. Average linkage to high gas months, so the 2 really cold months, your typical cold months, and your typical warm months. And the average, centroid, and median all give the exact same results as to which dot belongs into which cluster. Words like linkage basically just joined the green dots in the winter months, so it just makes 2 cutoffs, winter months and summer months. And you want to remember that's kind of the goal of cluster analysis. It's an exploratory method. We're trying to get the algorithm to group the data, and then we look at what those groups that they cluster together have in common. These months were the 2 really, really cold ones. These are your typical winter months, and these are your typical summer months. Sometimes the clusters make sense, sometimes they don't, and we're hoping that they make sense at the end of the day. If you want to get a little fancier with it, there's these functions that are based off of different packages you have to install, and you can see what those packages are at the top of this based off the libraries that we had to load. But this will make a little bit of a nicer dendrogram. You feed it the clustering method that you used. You can give it a name, and you have to specify how many clusters that you want. It'll form the dendrogram all the same. It'll just change the color of a bit. And this rect equals t will form a rectangle around the number of clusters you specify, without having to do it in a separate line that we did earlier. And it'll color code the 2 clusters that you form, and then draw rectangles around them as well. And if we change this to 3, it makes everything pretty simple because you don't have to rerun it. And we get, it looks like Ward's method, if you use k is equal to 3, kind of gives us the same results that we had for the complete linkage. And if you want a little fancier plot of the end results, what you can do is the same function that has the dendrogram and this cluster function that we're going to use has its own clustering method called hcut. You feed it the data. You don't actually feed it the distance matrix. You just give it the data that you want to use, the method that you want to use for HC underscore method. We want to use, we'll say single linkage. And then the number of clusters that you want. So you have to specify what k is equal to. It's not going to change the algorithm at all. It's just going to be used by this function down here to how many clusters we want to form. Well, let's change this from single to ward. .d. And then if we run it, kind of ignore the names up here. These are the 2 clusters that it formed. And these large shapes down here are the means of the clusters. Those are the actual centroids. We can change this then to centroid. Change it to maybe our centroid method. We said k should be equal to 3. And we can see the 2 months that it formed up here. The typical winter months down here. And then the summer months down here. It works out pretty well because we only have 2 variables, electric and gas. If you have 3 or more variables, like the crime data in the other example that doesn't have a video, it'll plot the principal components down here and tell you what percentage the principal components make up of the total variation. So if it said PCA1, 70%, PCA2, 20%, first principal component makes up 70% of the total variability in the data, and PC2 would make up the 20% of the variability in the data. But if you only have two, no need to use principal component analysis, so we'll just plot the original variables as is.